Okay, chapter 7.3, the unit circle. This is page 4, and we're going to do this one standalone because it's kind of important to pay attention to what is going on here. So we've got our two special right triangles. The top one is a 45, 45, 90, or an isosceles right triangle. The bottom one is our 30, 60, 90. You will notice that in both cases, the hypotenuse is 1. And just to double check, we can use the Pythagorean theorem to verify that we've got the lengths of these right. Ooh, hope you can read that. Theorem. We've got square root of 2 over 2 squared. Here's our other leg, square root of 2 over 2. We're squaring that as well, adding those together and seeing if we get our 1 squared. When we square radical 2 over 2, we get 2 over 4. So it's going to look the same here. 2 over 4 plus 2 over 4 is 4 over 4, which is 1. So that works. On our bottom one, we have got a side of square root of 3 over 2. We're going to square that. The other side is 1/2. We're going to square that. My hypotenuse is 1, so I get 3 over 4 plus 1 over 4. Again, that is 4 over 4, which is 1. So both of these are right triangles, and the sides are labeled correctly. So now we're going to go back to our trig ratios, and we're going to find the values for our trig functions. So sine of 45. Sine, again, is opposite over hypotenuse. So we can use either of these angles. They're both the same. The sides opposite them are the same. We get square root of 2 over 2 all over the hypotenuse, which is 1. And so sine of 45 is square root of 2 over 2. Keep in mind if the triangle's bigger, if the sides are longer and the hypotenuse is longer, that's still going to reduce to this, square root of 2 over 2. Okay, so I'm going down the left-hand side here. Cosine, adjacent over hypotenuse, still square root of 2 over 2 over our hypotenuse, which is 1. And we get square root of 2 over 2. Tangent, square root of 2 over 2, opposite over square root of 2 over 2. Anytime I divide a number by itself, I get 1. Given that the cotangent, I'm going to go this way, it's just the reciprocal of the tangent, 1 over 1, it's still 1. Okay. Cosecant and secant. Now, cosecant is the reciprocal of sine. So it's going to be 1 over my sine, which was square root of 2 over 2, which means this is just going to get flipped 2 over the square root of 2. Remember that we don't like having that radical in the denominator, so we're going to multiply numerator and denominator by square root of 2. We get 2 square roots of 2 over 2. Our 2's cancel, and our cosecant is square root of 2. Since cosine looks exactly like sine, the secant should look exactly like cosecant, so our secant is also square root of 2. Fairly straightforward. These you're going to need to know and understand, memorize, so that you can pull them out when you need them, which is going to be quite frequently. Okay, so example 6, sine of 30. So our 30-degree angle, that opposite side is 1/2. My hypotenuse is 1, and so the sine of 30 is 1/2. Cosine of 30 is our adjacent side, square root of 3 over 2. Over the hypotenuse, which is 1, which makes it square root of 3 over 2. tangent of 30 is, I'm going to write it over here so that I have a little more room. 1/2 over square root of 3 over 2, opposite over adjacent, which gives us 1 over the square root of 3. Again, we don't like that radical in the denominator, and we end up with square root of 3 over 3. That is our tangent of 30. Cosine of 60. Let's see if we can swap up colors here just a little bit. So our 60-degree angle, the side that is adjacent to the 60 is the 1/2. Hypotenuse is still 1. So the cosine of 60 is 1/2. And if you remember, sine and cosine are cofunctions. So the sine of an angle should be equal to the cosine of the complement. 30 and 60 are complements. So the sine of 30 should equal the cosine of 60. Okay. We have things in a bizarre, strange order here. Cosecant, I'm going to go down to K really quick. I don't realize that was all funky. Okay, so the sine of 60 should equal the cosine of 30. And if we take a look at our triangle, opposite the 60-degree angle is that square root of 3 over 2. Hypotenuse is still 1. So I get square root of 3 over 2. All good. Okay. Cosecant of 60. Cosecant is 1 over sine. So I get 1 over square root of 3 over 2. 1 over anything is the reciprocal function. It's really just going to take our denominator and flip it over. Or we can go back to the whole dividing by a fraction is the same as multiplying by the reciprocal. Both get you at the same place. So our cosecant is 2 square roots of 3 over 3. Okay, so now I'm going to be a little bit lazy. We're going to use our cofunctions. The cosecant of 60 should have the same measure. Let's see, our cofunction for cosecant is secant. Our complement of 60 is 30. So I'm looking for the secant of 30 that is up here on D. 2 square roots of 3 over 3. I could get it numerically using the same numbers I used to find the cosecant of 60. Again, 3 sides in a triangle. Only so many ways to combine them. Okay. So our cosecant of 30 would be the same as our secant of 60. I have not figured that out yet. So let's go back up here. Cosecant is 1 over sine. One over the sine of 30. Our sine of 30 was 1/2. 1 over 1/2 is the same as 2. Randomly put my hand down. Okay. Let's see what's up next. Where do you want to go? It would be nice if we could have a conversation here. So we've got the cosecant of 30. Let's see if we can use cofunctions again. The cosecant and the secant are cofunctions. 30 and 60 are complements. So the secant of 60, J, secant of 60 should be the same as the cosecant of 30. I'm going to put that over here. And so we get 2. Okay, tangent of 30 is going to be equal to the cotangent of 60. So that makes the cotangent of 60 square root of 3 over 3. And so we've got just these little bits left. Tangent of 30, tangent of 30 we have. Cotangent of 30 and tangent of 60 we're looking for. So tangent of 30 and cotangent of 30 are reciprocal. So I got 1 over tangent of 30 here. 1 over square root of 3 over 3 equals 3 over the square root of 3. We're going to rationalize that denominator. We're going to cancel our 3's. And we get square root of 3. Guess I should have done all the answers in the same color and all the work in a different. Cotangent of 30 is going to be exactly the same as the tangent of 60. We're using cofunctions, just like we did in 7.2.